All right, class. You know what's really sad is when you record a lesson and then something happens to the file, so you have to re-record it. So that's what happened to me. So that's not the most fun thing in the world. But I'll try to be just as enthused about doing this all over again. So today we are talking about 2.10, equations of tangent and normal lines. So do you remember doing this at the beginning of this unit where it kind of confused us and we didn't have all the tools yet we needed, so we're using kind of different definitions to find the slope of the tangent line? Well, remember that the derivative of function gives us the slope of the tangent line. So now that we're good at taking derivatives, we can use what we know about the power rule, the product rule, and the quotient rule to better help us find these. So let's recall that we have some curve, right? And that's this curve in the dark purple. And then we have a tangent line which just touches the curve at one singular point and shares the same slope, if you will, at that point. And then we have a normal line which is perpendicular to the tangent line. So we're going to be finding both the normal line and the tangent line. So let's go over the equation of a linear function. This is a version of point slope form, but you might recognize point slope form as y minus y1 equals. In this case, I just added y1 to both sides to solve for y. So we have y equals m times x minus x1 plus y1, where m is our slope and x1, y1 is our point of reference. So the two things we need in order to fill out this equation is a slope and we need a point of reference. And that point of reference is actually going to be the point where the tangent line touches the curve. So steps to find the tangent line. First, we need to plug the x value into f of x into our original equation to get the y value of the reference point, because we'll only be given the x value. So we need to find the y value. So that's step one. And then step two, we need to find f prime of x. So we need to take our derivative and plug in the x value to get our slope. So now that we have our slope and our reference point, step three is just plug into the formula. To find the normal line is really easy once we have our tangent line. So once you have the tangent line, just replace the slope with its opposite sign reciprocal. Because if you recall from, gosh, was it geometry maybe? When you have perpendicular lines, their slopes are the opposite sign reciprocal. So I just wrote that little note here. The slopes of perpendicular lines are the opposite sign reciprocal. So for instance, if we have like, let me do a different color. Say if we have like negative 2 as our slope. Well, negative 2 is really negative 2 over 1, and so the opposite sign reciprocal would be positive 1 over 2. So it would just be simple like that. So let's go over some examples here, and we will follow these steps. So here, oh, and I didn't write our c value, so c equals 2. All right. So our c value is really the x value of concern, but we just call it c sometimes. So this is really just the x value. And so that's actually going to be our x value of our reference point. This is going to be it's going to be 2 comma something is where our tangent line will touch the curve, or the more so, better put, it'll be the place on our curve that we want a tangent line to. Okay. So first we will find we'll plug in our x value into f of x to get the y value of the reference point. So I just need to evaluate this thing at 2. So f of 2 is equal to 2 squared minus 4 times 2 plus 3. which will give us 4, and then minus 2 times 4 is 8, plus 3. That's going to give us negative 1. So our point of reference that we're interested in is 2 comma negative 1. Okay, now that we have a reference point, we need to find our slope, and that's step 2. And to find our slope, we're going to take the derivative of f of x and plug in the x value and simplify and get the slope that way. So, let's see here. If f of x is this, f prime of x is going to be 2x minus 4. So let's see. Now now that we have the derivative to find the slope at that point, let's evaluate at that point. So we have 2, so f prime of 2 is going to be 2 times 2 minus 4. 2 times 2 is 4, so it's going to be 0. So now we have enough information for our tangent line. And hopefully this is much easier than last time. So we're going to use the form y equals, we're going to use this form up here, y equals m, and our m is 0, times x minus x1, so x minus 2, plus our y1, which in this case is negative 1, so it's going to be minus 1. So we found the equation of our tangent line. I do see something that comes up, though, and that is when we're trying to find our normal line here. Well, think of what 0 is. 0 as a fraction would be, we could just say 0 over 1, because every whole number is really over 1. But can we find the negative reciprocal of this? Let's think about it. It'll be positive goes to negative, and then it'll be 1 over 0, which we can't have anything divided by 0. So really there is no equation to the normal line in this case. So the reason I like this example is if you do have an example where a tangent line is 0 and you're asked to find the normal line, don't worry about it, because there won't be an equation for the normal line, because it'll be 1 over 0. Let's go ahead and graph these just so we can make sure our work is correct, and it's fun to graph them. So here's our f of x equals x squared minus 4x plus 3, and the equation of our point is at 2 comma negative 1. So our point is right there at the vertex, and that makes sense that the equation of our tangent line, the slope of it will be 0 anyway, because right at that point the rate of change is 0. So let's just plug this in. Y equals 0 times x minus 2 minus 1, and there you have it. That's the equation of the tangent line, or the tangent line point, or the line tangent to the point 2, negative 1. Okay. So let's go over a couple more examples here. And now we have x plus 2, x divided by x minus 2, and I forgot to write f of x. F of x equals, and our point of interest is c equals 3. So our x value is 3. So first let's find our point of reference. It's going to be 3 comma something. So let's plug 3 into our equation to figure out the y value. So f of 3 is equal to 3 plus 2 over 3 minus 2, which is 5 over 1, which is just 5. So our reference, or our point that we're concerned with, is 3 comma 5. Okay, so we have our reference point. Let's find our slope now. So we're going to take the derivative of this function. So we'll find f prime of x is equal to, let's see, so it's the low, x minus 2, times the derivative of the top, so times 1, minus the top times the derivative of the bottom, which is just 1, all over the bottom, which is x minus 2 squared, all divided by the bottom squared. So this is our derivative, and let's evaluate now at 3, because that's how we find the slope at that particular point. So f prime of 3 is equal to, let's see, okay, let's see here. 3 minus 2, so 3 minus 2. I'm not going to write this 1 because that's anything times 1 is just itself. So minus 3 plus 2, I just plugged in 3 for x. I'm not going to write that 1 again. All over 3 minus 2 squared. So continue to simplify. 3 minus 2 is 1. Minus, let's see, 3 plus 2 is 5, so 1 minus 5. Over 3 minus 2 is 1, 1 squared is just 1. So 1 minus 5 is negative 4 over 1, which is just negative 4. So our slope here is negative 4. So let's find, let's see, the tangent. Well, let's now create our tangent line. So the tangent line is going to be y equals our slope, which is negative 4, times x minus our reference point, so x1, so x minus 3, plus our y of our reference point, plus 5. And that is the equation of our tangent line. Now let's find the equation of our normal line, because we can do that this time. Okay, so remember, all we need to do once we have the tangent line is just take the opposite sign reciprocal of the slope and then use that as the slope, and we're going to use the same reference point. So see, we have negative 4 is really negative 4 over 1. Let me bring this up so you can see. So the opposite sign would be positive, and it would be 1 over 4. So the equation of our normal line is going to be y equals 1 over 4, because that's our new slope, times x minus 3 plus 5. And there you have it. We have the slope of our tangent line and the slope of our normal line. So let's go ahead and graph those for fun. So we have x plus 2 divided by x minus 2. So this is our curve here. And the point that we're going to be finding the tangent line to is going to be 3, 5. So it's going to be this point right here. And let's graph the tangent line. So y equals negative 4 times x minus 3 plus 5. There you have it. That's good. And then the normal line is y equals 1 over 4 x minus 3 plus 5. And awesome. There it is. You can see here in the red is the curve, and then the green is the tangent line at the point 3, 5, and then the purple is the line that is perpendicular to the tangent line at that point. So cool. Let's go over one more example here. And here we have f of x equals x times x minus 2. And let's say that we want it to find our c value at c equals 1. Yeah, we'll do it 1. Okay, so first we need to find our reference point. So it's going to be 1 comma something. And it's going to be, let's see, let's do negative 1. I think we'll get the same slope though. Let's do negative 1. Okay, so first let's find the y value. So we're going to evaluate the original function to find the y value. So f of negative 1 equals negative 1 times negative 1 minus 2, which equals to negative 1 times negative 3, which is just positive 3. So the y value of our reference point is 3. Now we will find the derivative and evaluate that at negative 1 to find the slope. So let's go ahead and find the derivative of this. So, and really quick, you know what? This comes up sometimes with the product rule, because in this case we would have to use the product rule. But what if I just do a little bit of algebra and reformat this so I could just use something easier and less messy, such as the power rule? And in this case I can. Because the power rule is our friend, right? It's the easiest of all the derivatives. So what if I just rearrange this like this? F of x equals x times x is x squared minus 2x, and then just use the power rule, which would be much easier because the product rule can be kind of long sometimes, and the longer things are in math, the more prone we are to making mistakes. So just a little shortcut. Now to find the derivative, f prime of x is going to be 2x minus 2. And then now let's evaluate at negative 1. To find the slope. So 2 times negative 2 is negative 2, minus 2 is negative 4. So again, we have a slope of negative 4. That's okay. So now let's find the tangent line. And the equation of the tangent line is going to be y equals our slope of negative 4 times x minus x1. In this case, x1 is negative 1, so it's going to be x plus 1 plus 3. And then our normal line is the opposite sign reciprocal of the slope. And just like last time, negative 4, same thing as negative 4 over 1, will turn into 1 over 4. So the equation of our normal line is y equals 1 over 4 times x plus 1 plus 3. And again, we'll go ahead and graph these just to make sure that we did them right. And again, it is just fun to do for me. Let's see, we'll get rid of these. So our function was f of x equals x times x minus 2. And our, let's see, our point was at negative 1, 3. So it'll be tangent to, at that point, and our tangent line is negative 4x plus 1 plus 3. There you go. And then our normal line is y equals 1 over 4 x plus 1 plus 3. So there you have it. In the black is our curve, and in the blue is our tangent line, and in the green is our normal line. So that's all I have for y'all today. Let me know if you have any questions. Get started on the worksheet. And hopefully this time around is much easier than last time. And I know it will be because we have more tools at our disposal. So that's all. Have a good day. And yeah.